Okay, first you have these, you have 3 sheets, and I want you to line them up like this. Just a little bit closer, okay. See those little dotted lines? You want to line that up with that. That little dotted line there. Okay, I'm going to make sure it's lined up properly. Then we're going to take the part that you lined up and we're going to line it up to this one. So your finished product is going to look like that. And put one little staple here in the middle to hold it all together. I don't know what I just did. We'll do that a little better. Okay, there we go. Now, the first part of this is greatest common factor. Okay? So for this one, we're going to factor out a 2. So that means divide each term by 2. So it's going to give me x plus 21y. Okay? Here, we're going to look at the GCF. So 4 goes into 4 and 24. And x cubed goes into x cubed and x to the 4th. So we're going to factor out at 4x cubed. Now, you don't have to write yours up under here, but I do that to keep up with what I'm doing. That cancels out. Okay. Well, let's do this one. So it looks like a 2 goes into both things, an A and a B. So remember, and you can put that right here where it says summary. Use the variable with the lowest exponent. Okay? So now we're going to factor both of these terms by, we're going to factor out a 2ab. 8 divided by 2 is 4. A squared over A is A. B over B cancels out. Minus 6 over 2 is 3. The A's cancel out. B squared over B is B. Here, okay, so we're going to factor out a 4. And the smallest exponents are x and y. Okay, 20 divided by 4 is 5. X squared over x is x. Y squared divided by y is y minus, and this term is simply a 1. Okay. Let's flip the page. And we're going to go over trinomial factoring. So remember for this one, and you can put down here in the summary, you can do your x. We want factors of c that add up to b. Okay, that's what we do. And I've noticed that people who use the x never miss. So you might want to consider that if you think you're, I don't know, too special for the x. So we want factors of 18 that add up to 11. That's going to be 9 and 2. So it's going to be x plus 9 times x plus 2. This is what I consider showing work, showing the x over here. See, if you go here and you get it wrong, then I won't know what you did wrong because you just wrote random stuff, okay? Here, same thing, factors of 14 that add up to 9. Of course, that's 7 and 2. So m plus 7 and m plus 2. Now, what if you accidentally put an x there? I'm going to take off half because the variable is m. Again, this is showing work over here. Um, Here, we want factors of 8 that add up to -6, positive 8, so that'll be -4 and -2, because -4 times -2 is a positive 8, and -4 plus a -2 is a -6. So this is going to be y minus 4, y minus 2. Now, what if you wanted to see if your answer was correct? I'm going to do the box method, which, or you can use FOIL. Y times y is y squared. Y times -4 is -4y. -2 times y. And you all are familiar with this type of area model. -4 times 2 is 8. So then we go, that's a y squared. -4y plus 2y is -6y. And then we have the plus 8, which is what we started out with. So that's how you check your answer. Now let's look at this one. We want factors of -15 that add up to a positive 2. And I'm thinking 5 times 3, but I want my 2 positive, so I'm going to make the smaller number negative. So 5 times a -3 is -15, and 5 minus 3 is a positive 2. So this is W plus 5 times W minus 3. Now, this is when A is equal to 1. That's what we call this one, A equals 1. Now, this one is when A is not equal to 1. And we still use the X method, but we do it a little differently. And in these types, just use the X method, okay? -15 times 3. My light just went off, but it's okay. -15 times 3 is a -45. And so we want factors of a -45 that add up to 4. So I did -15 and 3. So it's -5 and 3. That's 9 and 5, okay? And then we want to put it over 3. So we got 9 and 5. And it's got to be negative, but the number's positive, so we're going to do that. So here, 9 over 3 is equal to 3. So we got y plus 3. And then bottoms up. Okay. Same thing here. We want factors of positive 6 that add up to -7. And when we get those factors, we're going to divide them by 2. Okay? So that's going to be 6 and 1. Why would I say 7? And it's a positive 6 and a -7, so both of these need to be negative. So that simplifies to a -3. So we have x minus 3, and then bottoms up, 2x minus 1. Now, let's check our answer. This is one way for you to make sure that your answer is correct. So I put my x and my -3 there, my 2x and my -1 there. So x times 2x is 2x squared. 2x times -3 is -6x. -1 times x is -1x. -3 times -1 is a positive 3. So we got 2x squared. -6x minus 1x is -7x. And then we have the 3. So that's how you check your answers. For this one, I'm not going to go all the way through it, but I suggest that you factor out that -1 first. You can do it without it, but y'all, I'm grading 90 tests, so make sure you factor that. When you have a negative in front of that first term, just go ahead and factor it out. You'll thank me later. And then we want factors of 5 that add up to a -6, and we're going to divide it by 5. So that's going to be 5 and 1. It's going to be a positive 5, -6, so both of them need to be negative. So that's a -1, and then that's a, yeah. So we got m minus 1, and then 5m minus 1. Okay, you can do that one. Now let's look at our special products. We went over this. If we this is the difference of perfect squares. This would not work if this was a squared plus b squared. So for this one, we have to do the square root of the first term, which is a, and the square root of b squared, which is b, and of course, one is plus and one is minus. So if we have this one here, the square root of 9x squared is 3x. The square root of 16 is 4. This is sufficient. You wouldn't have to show any work. Now this one you would have to show work because it doesn't look like a perfect square trinomial, but it does have a GCF of 2. So we got 4 minus 9g squared. You need to show that step. You need to show that step. So we have 2 times 2 minus 3g and 2 plus 3g. Now these, I didn't teach this like this. I just taught you how to factor. I'm going to show it to you, but just factor it like normal. So if we have a polynomial, a quadratic in this format, that's just going to be a plus b squared. And this one is going to be a minus b squared. So like in this case for number 17, all I would have to do is factor square root of 4g squared, which is 2g, and square root of h squared is h, plus in that middle. And that's going to be it. But, you know, on the test, this is the way I taught you. Factors of 9 that add up to 6, 3, 3. So x plus 3 times x plus 3 is perfectly fine, okay? Just, you can factor it like that. That's something you'll memorize when you get into Algebra 2. For this one, it's going to be x minus 5 squared. But again, you don't have to memorize that. Factors of 25 that add up to -10. So it's going to be a -5 and a -5. And you would write it as x minus 5 times x minus 5. Okay? And this one is n minus 6 squared. Now, 4 terms, you know how to do this one. This one is already kind of grouped for you. So we got x minus 2, 5x plus 7. So that's already done. Same thing here. We got the m plus 3, and then -9m minus 5. This one, you just factor by grouping. You know how to do that. This one, you need to put in standard form. And then, of course, you would factor by grouping x squared minus 5. And you see your GCFs there. Now, these two are a little different. You'll have to factor out a -1 from the second set. So you're going to have 3y squared times y minus 2, and then minus 4 times, that changes the sign of everything, y minus 2. Then you can factor it. All right?